In this video, we're going to pick up where we left off, continuing with our next two parent functions. The next parent function is cubic. This is the function f of x equals x cubed, which means we multiply each input times itself three times. So again, we want to use the same inputs that we did on our linear and our quadratic to compare the three. So we're going to do -2, -1, 0, 1, 2. And this also lets us see the behavior or what's happening with negatives, with 0, and with positive. Okay, so multiplying -2 times itself three times. -2 times -2 is a +4, times -2 again would be a -8. -1 times itself one time, or -1 times -1 is +1, and then times -1 again is a -1. 0 times itself, no matter how many times, it's always going to be 0. So 0 cubed is 0. 1 cubed, 1 times 1 times 1 is 1. 2 cubed, 2 times 2 times 2 is going to be +8. Okay, so we don't have enough boxes or enough space to really graph -2, -8, and 2, 8, but we can do these right here. So that's how we'll see our graph. So we've got -1, -1, 0, 0, and 1, 1. Now, initially, if we just see these 3 points, it might look like it's just going to be a straight line again, like linear. But we also know that our next point, if we did -2, 8, -8, would be somewhere down here. So we have to kind of show that that's the direction that it's going in. So this is going to be a little squiggly like this, showing that the next point is way down here and way up here for +2. So that is the shape, kind of makes like a S shape. Okay, now looking at the domain, if you look here, again, we have all real numbers. For our inputs, all of our inputs. We can take any number and we can multiply it by itself 3 times. There's never going to be a number that we can't do that to. Then we look at our y values, our outputs, and that is going to be also, we have negatives, we have positives, and we have 0. So also all real numbers. Similar to linear in that way. So you should be able, over time, as we spend more time with this information and you spend time kind of getting it in your head, you should be able to say, all right, linear and cubic are the same in their domain and range, but they're different than quadratic. Okay, so you should be able to answer questions like that. Again, that was the cubic family, and it has changing slope as well. Okay. Now we're going to flip to our rational family. Our rational family is going to be f of x equals 1 over x. This is also going to be changing slope. And this means divide 1 by each input. So these are going to be really, really small fractions. Okay, we can have negatives on this, but we actually, and we're going to start just like we normally do, -1 or -2, -1, 0, 1, and 2. And we'll talk about 0 when we get there. So -2, if we input that, that's going to be 1 over a -2, -1/2, or -0.5 if you put it in a calculator. 1 over -1, that's just going to be -1. Now, if we go to our calculator and we put 0 in the denominator, we know that that is going to be undefined. And I'll show you what that looks like on the graph. Undefined, not possible, so you can just say UND. 1 in there is going to be +1, and then 2 is going to be +1/2. Okay, so let's put these in on our graph now. -2, I'm going to go, this is my x, this is my y as always. I'm going to go from my origin backwards 2, and then this is, if I go all the way down to the next tick mark, that's going to be 1, but I'm just going to go halfway. So that's the point -2, -1/2. And then we're going to have the point -1, -1. All right, looking kind of weird so far. The next one is going to be 1, 1. We skip over 0, because remember we said it's undefined, and 2, +1/2. Okay, because we skipped 0 and our axes represent 0 for both y and x, we're not going to have a 0 as our input, and there's also nothing that we can input to output a 0. So that means we're not going to ever cross the x and y axis, and that's really important for rational. They never cross. So this is going to be our shape. It's going to be 2 curves. They can get really, really close to the axes because we're going to get smaller and smaller fractions, but they will never actually cross the x or y axis. So that's what it looks like. So our domain is going to be all real numbers except 0. It's the only thing that doesn't work. And the same for our range. All real numbers except 0. All right, that concludes these next 2 parent functions, and we will explore these more in depth in the future.